Hello everyone, I am Robe and I'm responsible to do this presentation on behalf of my group, Group 2. In this presentation, we'll go through about the design principle and the methods of connection and joins. So before we get started the presentation, I'd like you to meet my teammate. Here they are. So I am Robe, presenter and the creator of this PPT. And then before we go to the presentation, I would like to have a look at the content, what we will go through in this presentation. Then the introduction. To understand the basic of connection and join, we have to understand what they are, what they do, and why they are being used. So for this, we have to understand who they are. So connection and joins are basically a part that connect or that assemble two objects or two devices each other. So as we can see in this picture, two steel bar are connected with the bolt and nut. The connection a connection in steel structure have the purpose and they are the connect different steel member and sheet to complete the structure to form cross section and members from the final steel making products such as cross section from steel plates, build up members from a rolled and welded section and plates to splice member which are delivered in partial length due to transportation restraint and form members of full length. So as let's have an example, let's have a look at an example. This is an example for steel structure, where as you can see in this structure they have used two types of connection. First of all is welded connection and the bolt connection, and then connection with a mechanical connecting media such as bolts, pin, rivet, screw, and the welded connection. So this is the welded connection, and the mechanical is called the bolt and nut and the screw and the are. So as our object to examine the gear reducer, as you can see, it's a picture of a gear reducer, and here we have seen a lot of holes, and those holes are used for the connection to establish this gear reducer in our desired position in our required machine or in our required object. The examples of a connection, there are various kind of, and they are the key joints, pin joints, and spline. The key joints, as we can see in this picture, the key joints and how they look. This is a kind of a rectangular, but those the both end is curve, has a curve. So this kind of key joint is used for the for the circular devices or for the gear reducer. So as we can see in this video, we have used key, like here key joints, and over here you can see is there is also key joints to connect them with the shaft. And then the cylindrical pins. To talk about the cylindrical pins, the pins to connect them to connect two objects by a pin. We can see the cylindrical pin, use of cylindrical pin. This is the first object of, you can see, first metal and the second first surface and the second surface. Oh, sorry, surface, and they use the cylindrical pin. As over here we can see also open and tapped pin, and this has a open end, like as you can see, those are go far from each other, then this is easy to remove them. And the tapped pin, as we can see, there's a kind of similar pin of cylindrical pin, but the dimension for the both end is not same. And the spline is a kind of pins that looks like a gear. As you can see, that this is the tooth for this kind of joints, and then here is a hole to meet or to fit this tooth. The structure of the cylindrical gears, as you can see, this is the isometric view, and this is the 2D view of the gear reducer, cylindrical gear reducer. So we'll go through each component over here. The first of all is the base. This one base is called a lower section, or lower of the box. And then number 2 is while indicator. So in this device they use the screw tighten device. I'll talk about this later. And then the number 3 over here, number 3 is this one is a cover. This upper cover or upper box or upper surface, you can say whatever you want. And then number 4 is vent, and then while inspection hole, or the inspection hole, this one we're talking about, this one. So and then number 6 is the hook, sorry, eyeball, or eye bolt, or you can see lifting bolt. And then number 7 is hook. There is a hook. And then number 8 over here is opening plug up, and number 9 over here is locating pin, and 10 is lifting screw holes. Use of the connection in the cylindrical gear reducer. So to cover the whole gear reducer, we use the nut to tighten up. So bolt and nut, this kind of nut they have used, but in different dimension to meet their requirement. And the key joints. So here we can see a hole for the key joints. So as in this picture, you can see the key joints of the gear reducer. And the eye bolt, or you could say this is a lifting screw, they have used for number 6. And to maintain this, to maintain the structural, stabilization, to maintain the structural stabilization, they use welded. You can see the welded section or welded metal to give the strength for this kind of structure. The ordinary bolts, this bolt is commonly used in this gear reducer. You can see a lot of holes over here, and then from this point of view, you can see this is a bolt and nut. To tighten up this gearbox, they use various kind of ordinary bolts and nuts. Through holes, machine precision is poor. The structure is basic. Installation and disassembly are easy, and ordinary bolts are often used. Then lifting screw is used to lift or to move the gear reducer one place to another place. And a lifting rings screw are usually located on the top of the machine or a cover cell. Screw connection. So screw connection screwed into a threaded hole of joint pieces, simple, compact, and constructive. So as we can see, is a lot of holes over here. So we cannot see the nuts. So what they did, inside the hole, the hole is a thread, and we use the screw connection to connect in the assembly section. Discuss about the design criteria. Strength calculation of a bolt. connection is mainly related to the assembly connection, preload and non-preload, the nature of external load and material performance. The strength calculation for a load has two criteria. The first of one is a loose of the bolt connection and the tightened bolt connection. So as you can see, the equation to measure the strength for the bolt connection, and then I'll talk about the connection strength connection of a tightened bolt. Tightened bolt connection is, there are three kinds, and they are tight bolt connection with pretension, tight bolt connection with under axial load, tight bolt connection with under shear load. So I have taken this picture from our teacher's PPT, which is very helpful. So to talk about the tighten bolt connection with a pretension only, then as we can see, the force force action of line is perpendicular to the to the surface, to the surface. So this is called the pretension only, and this is the equation. You can go through all of them, and you can get the value for the strength condition. So this is the equation for the strength condition. As if you fulfill the condition, that means your device or assembly object is ready to use or to commercialize for the next use. And then the tight bolt connection under axial load. As the bolt with the preload F0 is, sorry, this is the question, but as we can see in this picture, the action of line and the load is not perpendicular, but is a parallel to each other. So to understand this phenomena, you have to calculate them from the equations, and then the tight bolt connection with under shear load. So to understand, we have to understand before what is shear load. Shear load is basically shear the load between two plates. So as you can see in this picture, this is the two surface, and we have connected with one bolt and nut. So the action of line, action of the force line is opposite. You can see the opposite direction, but they are parallel, but they have some the fluctuation, or you could say that they have share a distance between the action of line, action of force line, or action of a load line. As you can see in this, over here, the action of line for this plate is in this direction, and for this plate is in this direction. But oh, sorry, so they share a minimum distance of they share the minimum distance for the opposite force, due to opposite force. So that's why this bolt under extreme under extreme load, this will share like in this way. They will share like in this way. I hope you understand what I try to mean. You can, if you have any question, you can ask me after presentation. As the time is so limited, that's why I couldn't describe it more. So hope this will help you to understand the basic principle for the tight bolt connection, or strength of the strength. Okay, so this is my presentation. Thank you. If you have any question, or you can if you have any suggestion, you can give me. And I am very much sorry about my internet connection. As you know, this is not in my hand. So I hope you understand my situation, and thank you, all of you.